Finding Nemo, you probably appreciate the fact that sea turtles are among the elite navigators of the animal kingdom. They cross entire oceans surrounded by dark, featureless water in order to return years later to their original nesting grounds. As a human who needs visual cues like landmarks and street signs to navigate, this is amazing. And also perplexing, because while we know that sea turtles can sense the Earth's magnetic field, and that this is somehow related to their ability to navigate, the magnetic receptors which enable this magnetic sense have never been identified in any animal. To help answer this long-held question, and to understand this impressive navigation technique, my project is to design and build a special imaging system which is able to both detect and locate magnetic receptors in sea turtles. To do this, I need to build a system that, 1, is really sensitive to magnetic material, 2, that has really high resolution, because these particles may be really small, 3, that's fast, because sea turtles are pretty big, so we have a lot to scan through, and 4, that can do all this without destroying the tissue, because sea turtles are endangered. No current methods meet all 4 requirements. So I propose to use a relatively new optical imaging method called OCT. And basically, OCT is very similar to ultrasound, which many of you have probably heard of. The main difference is that rather than using sound waves to form images, as in ultrasound, we use light waves from a laser. By using light, we shrink the scale of the imaging down, so that our resolution is much better than that of ultrasound. I then designed and built an electromagnet to give us sufficient magnetic sensitivity. I place the magnet over the tissue I'm imaging, and I tell it to create an oscillating magnetic field, so that any magnetic receptors in the tissue will oscillate up and down in sync with that applied field. I can then look at the images and pick out any pixels which have these oscillating particles. And by doing this, we've both detected and located the magnetic receptors. So after building the system, I wanted to test the method by first imaging a sample with added magnetic particles before imaging animal tissue. So I imaged tumor cells, which had been treated with a drug containing small magnetic particles, and I was able to detect magnetic signal arising from those added particles. And the signal was larger for the samples with more particles. So these results are really promising for 2 reasons. On the one hand, I've shown that my system is able to detect magnetic particles embedded in tissue, and I'm now poised to image animal tissue and hopefully shed some light on this navigation question. And on the other hand, our results show that this novel imaging system may have biomedical applications, such as investigating disease treatment options. Our future collaborations will explore these applications as well.